Ever wondered how a robot could understand your voice and then do something complex, like pouring a drink or climbing over a couch? It's not magic. It's a breakthrough in robotics called LeVERB, and it's rewriting the rules of how machines learn to move. Let's dive into how this system is teaching robots to navigate the real world with human-like adaptability, all while learning from virtual environments. Here's the challenge. Traditional robots operate like pre-programmed automatons. You input exact commands, move this joint 30 degrees, rotate that arm, and they execute. But the real world isn't a script. It's chaotic, dynamic, and full of surprises. That's why most robots struggle with tasks requiring flexibility, like dodging a moving object or figuring out how to sit on an unfamiliar chair. They lack the ability to adapt on the fly. Enter LeVERB, a system that gives robots a two-tiered intelligence. The first tier acts as the robot's sensory cortex, processing language and visual input to decode commands like grab the red cup or walk toward the desk. The second tier is its motor control hub, responsible for translating abstract goals into physical movements. But here's the key. LeVERB doesn't rely on rigid instructions. Instead, it learns through experience, much like humans do, by analyzing patterns in data. So how does it learn? Researchers bypass the expense of training on real robots by creating a virtual training ground with 150-plus tasks, from navigating rooms to sitting on chairs. They generated synthetic data by retargeting human motion capture sequences onto digital robot models. But they didn't stop there. They injected realism by randomizing lighting, backgrounds, camera angles, and even mirroring movements to simulate real-world variability. This synthetic yet diverse dataset becomes the robot's textbook. What sets LeVERB apart is its hierarchical architecture. At the top, a vision language policy deciphers commands and creates an abstract plan for the robot, like a human visualizing a trip. Below, a latent action generator translates that plan into precise motor commands, balancing joints, adjusting grip, and reacting to obstacles. This separation of what to do and how to do it allows LeVERB to handle both straightforward tasks and unpredictable scenarios. Think of it as a robot's toolbox of movement patterns, dynamically selected based on context. The outcomes: LeVERB achieved 80% success on simple tasks and 58.5% overall, a significant leap over prior systems. For example, when told to grab the red cup in a cluttered room, it doesn't follow a fixed sequence of joint rotations. Instead, it draws from its learned latent action vocabulary to balance, reach, and lift, adapting in real time. This isn't just efficiency, it's a paradigm shift in how robots perceive and execute tasks. So why does this matter? LeVERB isn't just about robots following orders. It's about bridging the gap between simulated training and real-world unpredictability. By learning in virtual environments that mimic reality's chaos, robots gain the adaptability to handle surprises, much like humans. This could transform industries, from household assistants that tidy your room to disaster response robots that navigate rubble. Next time you see a robot, ask yourself, what if it could understand you, not just obey? The future of robotics isn't about speed or strength. It's about flexibility, learning, and resilience. And LeVERB is leading the charge. What do you think? Would you trust a robot to tackle a messy room? Let me know in the comments, because the future isn't just being built, it's being imagined, and you're part of the conversation.